So we have this band, they separate that into two. So even they don't give us the figure, we can draw that. So rectangular band separate into two, and so this length equal to this length. Yes, we have y, y, y. Here we have x, the whole thing is x here. Now we need to find the maximum possible area. So let's set up the formula we have, the condition. They give us that this is 400 feet of fencing. So this means that the total length they use here, if you compute the sum, you get 400. So we have x plus y, y, y. So this means 2x plus 3y equal to 400. What is the maximum possible area inside the paint? So the area is the total area here. So let's look at the big rectangle. So you have one side is x, the other side is y. So you have area equal to, let me denote area by a, x times y. This is the area. And we want to get the maximum area. So maximum area. So we want this to be max. So for this type of question, you look at this area is x times y, but x, y are related by this formula. You can write down area in terms of x or y. So for this kind of question, I could write down the interval or the domain for x and y. So for example, x and y here are length, so they must be at least 0, so they are all positive. We also know that this sum is at most 400. So 2x is at most 400. 3x is at most 400. Because each term is at least 0. So you know that this one 400 is bigger than 2x, and 400 is also bigger than or equal to 3y. So this gives us the upper bound for x and y. X at most 400 divided by 2, 200. Y at most 400 divided by 3. So it seems x is nicer. I will write down the formula here in x. So remember that our x is at least 0, at most 200. X bigger than equal to 0, less than equal to 200. And because of this formula, we know that 3y equal to 400 minus 2x, y 400 minus 2x over 3. So xy, a equal to xy, area x times y equal to x times, here's our values for y with respect to x, y equal to this. So this one gives us area equal to x times 400 over 3, 2 over 3 x. Area is minus 2 over 3 x squared plus 400 over 3x. Now we have area as a function in x. Oh, I can write down that one as a function in x. So we want this one to get maximum. We get the maximum area. So this means that we get the max for A on the interval, on this interval. So find maximum AX when X between 0, and you see that of course X cannot be 0, right? Or Y cannot be 0, because otherwise this one is not a pent anymore. It's not a rectangle anymore. So now all we need to do is compute the critical points, right? So this is a nice function. You compute A prime of X, you get the critical points, you compare with the endpoints is necessary. So now let's do it. A prime equal to minus 2 over 3 times 2x 400 over 3 equal to, let me group 4 over 3 outside, minus x plus 100. This one equal to 0 if and only if x equal to 100. So we have only one critical point, x between 0 and 200. Our critical point is 100. A prime of x equal to 0 when x equal to 100. When x less than 100, 100 minus x positive, so this is positive here, negative here. Ax, so this is increasing and then decreasing. So we have a max right here. So max of the area is when x equal to 100. So A of 100. Area when x equal to 100. So area is this formula. We need x equal to 100. So minus 2 over 3, 100 square, 400 over 3 times 100. This is the area. So we have 100 square minus 2 over 3. So yes, I want to do the same. 2 over 3 times 2 times 10,000. So we have 2 over 3, 10,000 minus 1 plus 2. So this gives us 20,000 over 3. This is our max of the area of the pens we need to find. The question is, what is the maximum of the area inside the pens? The conclusion is the maximum area inside the pens is this one.